The difference between adding and multiplying polynomials is when you're adding, you have a plus sign between the parentheses, and when you're multiplying, you don't have anything between the parentheses. Another example to remember is this. 2x plus 3x altogether is 5x. When you multiply 2x times 3x, your answer is 6x squared. So basically when you're adding, you leave the exponents alone, and when you're multiplying, that's when you add the exponents, just in case you got the two confused. So let's go ahead and do that in example 1. We're going to multiply a monomial, one term, by a polynomial, many terms. So it looks like in A, we have the one term out front. All of that counts as 1 because it's all stuck together by multiplication. And we're going to multiply it on the inside by that term and by that term. So this is basically just distributing. So we'll multiply there and we'll multiply there. What do we multiply first? We'll do the plain numbers first. Negative 3 times 2 is negative 6. Then we'll deal with the x's. We have x squared and x to the third. So 2 plus 3 is x to the fifth. And then we'll multiply the y's. Y squared times y to the second, plus y to the first is y to the third. Next we'll do the second term. So negative 3 times 4 is negative 12. X squared times this x right here, 2 plus 1 is x to the third. And last we'll add the exponents on the y's. Y squared times y to the fourth is y to the sixth. These are not like terms because the letters have different exponents, and so that's the final answer. When we do B, we will take the one term out front and multiply it by each of the 3 terms on the inside. So we'll multiply a to the first times a to the third. That will give us a to the fourth. We'll multiply b to the first times no more b's, so we just have b to the first still. Next we'll multiply technically a 1 in front times 3, which is still 3. Now let's multiply the a's. A to the first times a to the first is a to the second. And now we'll multiply the b's. B to the first times b to the second is b to the third. Last we'll multiply 1 times negative 1. That would be negative 1, or just a negative sign. We'll multiply the a times, there aren't any a's, so we still have just one a to the first. And then we'll multiply the b's. B to the first times b to the third is b to the fourth. None of these letters have the same exponent, so that's the final answer. FOIL is specifically designed for binomials times binomials. That's when you have 2 terms times 2 terms. So when we multiply the first items, I will use blue, and when we multiply the outer items, I'll use blue. And when we do the inside ones, I'll use red, and when we do the last terms, I'll use red. So there's my color coding for that diagram. So let's go ahead and multiply the first items. So x times x is x to the second. Now the outside, x times negative 4 is negative 4x. Now we'll multiply the inside. 4 times x, that's positive 4x. And positive 4 times negative 4 is negative 16. Now we just combine like terms. So we put the x's together. Negative 4 plus 4 is 0. So our final answer is x squared minus 16. When we multiply b, we have to write out the perfect squares next to each other. So we have 2 of those. We have x plus 5, and next to it we have x plus 5. Now we can FOIL it. So I'll do the first in the outside. So x times x is x squared, and x times 5 is 5x. Next, I will multiply the inside and the last. So the inside is also 5x, positive, and positive 5 times positive 5 is positive 25. When we combine these like terms, 5 plus 5 is 10. So our final answer is x squared plus 10x plus 25. I'll show you two ways to multiply larger polynomials. In this case, we have a 2 by 3. So first I'll show you the FOIL way, and then I'll show you the box method. So the FOIL way, we'll take this x, and we're going to distribute it to the 1, to the 3x, and to the negative x squared. So let's do that first. X times 1 is x times 3x is plus 3x squared, and x times negative x squared is negative x to the third when we add those exponents. Now I need to distribute the negative 2. So I'll do negative 2 times 1 times the 3x and times the negative x squared. So negative 2 times 1 is negative 2. Negative 2 times 3x is minus 6x. And last, negative 2 times negative 1x. Negative 2 times negative 1 is positive 2x squared. Now we go through and find our like terms. Don't forget we should write our answers in standard form. So we should put the negative x to the third first. Then we'll put the x squareds together. I have positive 3 here and positive 2 there. So altogether that's 5x squareds. Next, for the plain x's, I have 1 right there and negative 6 right there. So 1 minus 6 is negative 5. And last we have the minus 2. So there's the final answer to that one. When we multiply polynomials bigger than 2 by 2, I actually like the box method a little better. We have 2 terms here and we have 3 terms here. So we're going to draw a box that's 2 by 3. I prefer to make my boxes kind of sideways, so I'll make it 2 on the side and 3 on the top. So on the side, I'll put the x and the negative 5, and on the top, I'll put the 2, the positive 4x, and the negative x squared. Now we just fill in each of those boxes by multiplying, and then we'll combine like terms at the end. So in the first box, x times 2 is 2x. In this next box, 4x times x is 4x squared. In the next box over, we'll have negative times a positive, that's negative, and x squared times x to the first is x to the third. On the bottom row, negative 5 times 2 is negative 10. Next we'll have negative 20x. And last, negative 5 times negative x, that will be positive 5x squared. Now we just look to combine like terms for our final answer. So the highest exponent is x to the third, and there aren't any more of those. So negative x to the third goes first. Now it looks like our x squareds are on a diagonal right there. 4 plus 5 is 9. So we have 9x to the seconds. These x's we can put together. 2 minus 20, or negative 20 plus 2, is negative 18x. And last we have the minus 10. So that's the final answer. It does not matter to me if you do the FOIL way or the box method way. As long as you can do the problems, that's fine. Good luck.